Hey everyone, Dankman here. So we'll continue our introduction to Unit 4, 4.1. So we're going to introduce today what exactly is, or at least introduce the concept of a system of equations, and I'll hop right to it. Okay, in our class, a system of equations is simply going to be more than one equation. Okay, so two equations or more, and we're almost entirely going to deal with two equations. So two, we'll occasionally look at maybe three, two or more equations, and we're going to say with the same variables. And that's a little bit vague. That's a little bit vague. So I'm going to say that these equations are just interrelated or dependent on each other. Okay, connected. Interrelated or connected. So we're going to look at two or more connected equations. That's it. And that's a little vague sounding, a little abstract really. And so we're going to look at a concrete example. Okay? And so I'm going to have two or more equations. So we'll start with two. Okay, and they're going to be linear equations, all right? And I'm going to have y equals 2x plus 3, which is a line with a slope of 2, and a y-intercept of 3. And I'm going to have the equation y equals negative x plus 6, and that's a line with a slope of negative 1 and a y-intercept of 6. Okay, and I think the first thing I do often when I think about a function or a two-variable equation is I think about what it looks like when you graph it so that I can get a picture of how it behaves. So I will graph these two equations now. Okay, so we're going to put them on our axes. All right, y and x. Okay, and the y-intercept of 3 and a slope of 2 is going to look more or less like this. Get my ruler on those 3 points, and you should be graphing these two more or less like that. Okay. And maybe I'll go ahead and label that one equation A. And this can be equation A. And the next one has a slope of negative 1 and starts up at y equals 6. Okay, so I'll make a graph of that one. And that line we can go ahead and call line B to match with equation B. If it helps you to put these in color, we could put them in color. Okay, so now we have two equations, and we're going to talk about how they're interrelated or connected, and what exactly I mean by them having the same variables inside of them. Okay, to do that, I want to remind you about solutions. Okay, the last video was about the fact that any point that I pick on line A, for instance, this point, which is the point 2, 7, is a solution, or has the coordinates that are a solution to that line's equation. Okay, so if I plug its coordinates into the equation for x and y, then that equation is satisfied. And any line that I pick that's not on line A won't satisfy its equation and won't be a solution. And the same thing is true for line B. Okay, if I pick the point 3, 3, and I plug that in to line B's equation, I get 3 is equal to negative 3 plus 6, and therefore 3 equals 3, and it's satisfied. So any point on the red line has coordinates that solve the red equation, and any point on the blue line has coordinates which are a solution to the blue equation. And you can see now quite clearly that there's only one point that's on both lines. That's the point 1, 5. Okay? And so both equations have some solutions that are not shared between them. Both lines have points that are not shared between them, but there is only one line, there is only one point, and that's the point 1, 5. And if I plug the coordinates 1, 5 into equation A, then I get the following property, okay? Equation A is y equals 2x plus 3, or the following result. I replace the letter y with the number 5. I replace the letter x with the number 1. And in this way, I get 5 is equal to 2 plus 3, and the equation is satisfied. So the point 1, 5 is a solution to equation A, and it's a point that's on the red line, on line A. And the same thing is going to be true for equation B. If I take the point 1, 5 and I plug it into equation B, then I put 5 in for y. I put 1 in for B, 1 in for x, sorry. On the left-hand side then, I get 5, and on the right-hand side I get negative 1 plus 6, which is 5, and it is satisfied. So the point 1, 5 solves equation A and solves equation B. The point 1, 5 is on line A and it's on line B, and it's the only point that's on both lines, and therefore it will be the only ordered pair, the only set of numbers that is a solution to both equations, okay? And so a solution to a system of equations solves both equations. And I sometimes like to say simultaneously or at the same time. And we can also say sometimes all, because what if there were 3 equations, etc. So let me say again, a solution to a system of equations solves both equations simultaneously or at the same time. It's a pair of numbers in this case because there are 2 lines and they all have points, and all points in our class have 2 coordinates, okay? So these 2 coordinates, 1, 5, simultaneously solve equation A and equation B, and that point is the only point that is on both line A and line B. And that is what a system of equations means. We're going to look at 2 equations at the same time, and we're going to look for a solution that solves both equations simultaneously. And visually, it's going to look like 2 different curves for 2 different functions, and the point that is on both functions is the point that has coordinates, which will solve both equations.